Okay, Honors Pre-Calculus BC, Section 4.6, Day 1. And we are going to be starting to talk about our complex zeros. Up until now in this chapter, with the exception of the appendix that we did right at the beginning, we have only been talking about real zeros. So now we're going to start looking at our complex zeros. All right, we're going to start right here and say for a quadratic equation in this form, ax squared plus bx plus c is equal to 0, then we know we can solve for x using the quadratic formula, and we will get that x is negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, now for some interesting pieces of information, let's find the sum of those two zeros, because this is two zeros up here. So let's find them. One of them is negative b plus the square root of b squared minus 4ac over 2a. And we're going to add on negative b minus the square root of b squared minus 4ac all over 2a. When we add these, we have common denominators, so we can add the fractions. That will be over 2a. And up in the numerators, we have a negative b plus another negative b. That's negative 2b. And this square root of b squared minus 4ac minus square root b squared minus 4ac. Those subtract out, they're gone. And we just have negative 2b over 2a, which is negative b over a. All right. Now, how about the product of the zeros? So let's multiply these guys. Negative b plus the square root of b squared minus 4ac over 2a times negative b minus the square root of b squared minus 4ac all over 2a. All right, denominators, again, easy. 2a times 2a, 4a squared. Up in the numerator, we're going to have to FOIL this out. Negative b times a negative b. That's b squared. Then negative b times this opposite of this big square root. That's going to be positive of b times that square root. And then this one right here on the inside terms, that'll be negative b times that square root. So those two will subtract out. And then we're left with minus the product of those last ones, which is the quantity b squared minus 4ac. And simplifying this, b squared minus b squared, subtract out, minus a minus 4ac. That's 4ac over 4a squared, which simplifies to be just c over a. All right, so tying this all together, this says for a quadratic equation in the form ax squared plus bx plus c equals 0, then the sum of the zeros is negative b over a, and the product of the zeros Excuse me. Simon, I'm recording. I'm recording. You're going to have to wait. Sorry, you guys. Product of the zeros is c over a. All right, now, so let's take a look at a few examples. If we have this one, x squared plus 7x plus 12, find the sum and the product of the zeros. The sum is just opposite of b over a, so negative 7 over 1, or negative 7. And the product is c over a, or 12 over 1, or just 12. How about this one? Right here, the sum is opposite of b over a, so 19 over 3, and the product is c over a, negative 42 over 3, which simplifies to be negative 14. So you don't have to find the zeros and then add them together, or find the zeros and then multiply them. If you know this neat little thing, you know the sum and the product of those zeros right off the bat. Okay. Also, we can look at this. If ax squared plus bx plus c is equal to 0, could I take that and divide everything by a? So then that becomes x squared plus b over a times x plus c over a equals 0. Now, how about this piece right here? Again, x squared minus a minus b over a times x plus a c over a equals 0. All right, what's this? Yeah, that's the sum of the zeros. And what's this? That's product. So if you know the sum and you know the product, you can write the quadratic equation. Sum and product of the zeros. So if you know the sum and product of the zeros, you can write the quadratic equation as x squared minus the sum of the zeros times x plus the product of the zeros equals 0. That is a nice piece of information to know. It's required that you know that piece of information as well. All right, let's go ahead and look at some examples. I would like you to write the equation of a quadratic function with zeros are 2 and 6. And there are 2 ways to do this. And I will show you both ways, and then you can decide whatever makes you happiest. And sometimes one way is easier than the other. So, one of the ways is something that we've done before, and that is if we have zeros of 2 and 6, then the factors that produced those would have been x minus 2 and an x minus 6. And then we could just distribute through, which would be x squared minus 8x plus a 12. I can't see it. Yeah, go ahead. All right, here's the other way. You know the zeros are 2 and 6. What's the sum of those zeros? The sum is 2 plus 6, which is 8. What's the product? The product is 2 times 6, which is 12. So we could jump right into f of x equals x squared minus the sum, minus 8 times x, plus the product, plus 12. Okay, for this one, the difficulty is pretty much even. Look at this next one though. I want you to write the equation of a quadratic function with zeros 3 plus the square root of 5 and 3 minus the square root of 5. So if we look at these 2 ways again and look at the difference between them, the first way is we would have to set up the factors for those. So that would be x minus this 0, 3 plus square root 5. And then the second factor would be x minus a 3 minus square root 5. Thinking about multiplying that out, we have to distribute this minus through, so this would be x minus 3 minus square root 5 times an x minus 3 plus square root 5, and then multiply those 2 together. Yikes. What about the other way? the sum of these two solutions? 6. What's the product? We would just have to multiply these. So think FOIL. 3 times 3 is 9. And then a minus 3 square root of 5 plus 3 square root of 5. That's subtract out. And then we have minus square root of 5 times square root of 5. Minus 5, which is 4. Look at this now. Oh my goodness, I'm so sorry. Sorry. F of x equals x squared minus the sum 6x plus the product plus 4. Yay, done. See how much nicer that way is? If for harder zeros, this way is tons easier. All right, there are some general conclusions. Many of these we have talked about before. Most of them you've seen, we just haven't kind of ironed everything out or actually kind of labeled it. There are some general conclusions. So the first one is that the number of zeros is exactly equal to the degree of the polynomial. So a degree 3 is going to have 3 zeros. Now, they could be 3 that all have a multiplicity of 1, or excuse me, 3 different zeros that all have a multiplicity of 1. That could be the same 0 that has a multiplicity of 3. So we if we count the multiplicities, the number of zeros is the same as the degree of the polynomial. Odd degree polynomials have at least one real zero. An odd degree polynomial must cross the x-axis at least once. Maybe more, but at least once. Okay, another one. For a polynomial with rational coefficients, okay, so no square roots as coefficients. No square roots as coefficients, no i's as coefficients, etc. For a polynomial with rational coefficients, irrational zeros occur in conjugate pairs. For example, if a plus the square root of b is a 0, that's irrational. It's real, but irrational. So like 2 plus the square root of 3, 5 plus square root 7. If that's a 0, then a minus square root b, its conjugate, is also a 0. Okay, look at this next one. For a polynomial with real coefficients, complex zeros occur in conjugate pairs. For example, if a plus bi is a 0, then, what do you think? Yes, a minus bi, its conjugate, is also a 0. let's go ahead and take a look at some more examples here. Whew. Okay, I would like you to find the remaining zeros of this polynomial if it has real coefficients, and we have a degree 3, and the zeros are 4 and 3 plus I. Well, degree 3 says we should have 3 zeros. There's one of them right there at 4. One of them is 3 plus I. Where's the third one? Yeah, the conjugate, 3 minus I. All right, how about this one? We have a degree 5. Degree 5 has the zeros at 0, at 3 plus the square root of 2, and 4 plus I. We need a total of 5 zeros. One here, one there, one there. I gave you 3 of them. Where's the other ones? Yes, conjugate pairs. So 3, minus square root 2. And then the other one is 4 minus I. All right, look at this one. Okay, I would like you to form a polynomial with real coefficients of degree 3. Zeros are negative 3 halves and 1 minus the square root of 6. All right, right here, once you see this one, this has to tell you immediately that 1 plus the square root of 6 is also a 0. All right, so now we're going to form a polynomial with real coefficients, degree 3. Okay, what's the factor that produced that 0? That produces a negative 3 halves? That's 2x plus a 3. You don't want to use x plus 3 halves. Use 2x plus 3. It's going to be much nicer to deal with. All right, then this one, for these two zeros, we could say x minus that 1 minus square root 6, and x minus the 1 plus square root 6. But what a mess if I want you to multiply this all out. So instead of writing it this way, why don't we take this and use the sum product idea to get an expression that has the zeros for 1 minus the square root of 6 and 1 plus the square root of 6. Use this x squared minus the sum times x plus the product idea to get a quadratic that would produce zeros 1 plus or minus the square root of 6. So what's the sum of those two solutions? 1 minus square root of 6 and 1 plus square root of 6. That sum is 2. What's the product? 1 times 1 is 1. Middle terms are going to drop, and then we'll have minus 6. So that's negative 5. So this quadratic is x squared minus 2x minus 5. X squared minus the sum plus the product. And let's take that and put that right up here. X squared minus 2x minus 5. And then let's just bring down that 2x plus 3. Now multiply this out. All right, so I'm going to do 2x times each of these things and then 3 times each of those. 2x times x squared, that's 2x cubed. 2x times a minus 2x is minus 4x squared. 2x times a minus 5 is a minus 10x. Then a 3 times each of those, 3x squared. And I think I've taught you about the vertical multiplication here, so I can write my terms already collected. So that's going to be a minus 6x and a minus 15. Now when we add those up, our polynomial is 2x cubed minus x squared minus 16x minus 15. There it is. There's your polynomial right here. That has zeros of negative 3 halves and 1 plus or minus the square root of 6. All right, last one for today. I would like you to form a polynomial with real coefficients degree 5, so 5 zeros, with zeros 1, which has a multiplicity of 3, and in a 1 plus I. All right, that 1 plus I, that one's telling us that 1 minus I is also a 0. Okay? All right, so here we go. Zeros, 1. That's going to give us a factor of an x minus 1. Multiplicity 3. Then let's get the quadratic for these two complex zeros. X squared minus the sum times x plus the product. X squared minus the sum is 2x plus now product. Ooh, I better go over here. Product is 1 times 1 is 1. Middle terms dropped, and then we have minus I squared. And that'll be a 2. So the product is 2. And let's take that right back over here. X squared minus 2x plus a 2. Now we have to multiply this mess out. All right, I do want to come down here to the bottom and just refresh your memory on something. There is a difference between a plus b cubed versus a cubed plus b cubed. Those are not equivalent. Not equivalent. The a plus b cubed, that's typically our factoring, our SOAP factoring. A plus b times a squared minus ab plus b squared. That's factoring. This one, we want to cube that out, and there's a pattern for this. It's a cubed plus 3a squared b plus 3ab squared plus b cubed. And that is an expansion, multiplying out. Notice the pattern on the a's. A cubed, then an a squared, then an a, then no a's. The b's go the opposite direction. No b's, 1b, 2b, 3b. The coefficients, 1, 3, 3, 1. So we can use that idea up here when we want to take this x minus 1 and cube it. That's got to be the a cubed. So here's the a. There's the b. So there's x cubed. That's like the a cubed. Plus 3 times the a squared times b to the first, so negative 1, plus 3 a, which is 3x, times b squared, so a negative 1 squared, plus b cubed, negative 1 cubed. That's all times this x squared minus 2x plus 2. All right, cleaning this up inside of here, we're going to have x cubed minus 3x squared plus 3x minus 1 times an x squared minus a 2x plus a 2. Okay, let's go ahead and multiply. Each of these terms times each of those terms. X cubed times an x squared, x to the fifth, x cubed times a minus 2x. Minus 2x to the fourth, x cubed times a 2, plus 2x cubed. And then the 3x squared times each of those is a minus 3x to the fourth, plus a 6x cubed, minus a 6x squared. 3x times each of those is 3x cubed, plus 6x squared, plus 6x, and then last one is a minus x squared plus 2x minus a 2. See, isn't it nice to write it vertical? Then your terms are already collected. You just need to add down the columns. So we will have an x to the 5th minus 5x to the 4th, 2, 8, 9, 10, 11, plus 11x cubed. 6, whoa, do I have a sign wrong right here? Where was this one from? Third one. Oh, I certainly do. 3x times a minus 2x right there. And I bet some of you are having a heart attack because I did that. We'll catch it. Minus, and that's going to be a minus 13x squared. And then plus an 8x minus 2. There's your polynomial. Done. Yay. Thank you very much for tuning in.